All right, this is going to be a rather short session as there's no audience. I'll try to cover it very quickly. And as always, we'll try to just cover two, three new concepts and try to connect it to the overall domain modeling theme, like how is it all tying up. So till now, what we had covered till now in our first two session has been the fundamental of like what's a domain model, what's the importance of it, uh, the whole exercise and importance around having common language with your domain experts and how it needs to translate to your code. Then a person who is coding also needs to be involved in that overall modeling exercise and vice versa. Then in the last session, we started covering some basic building blocks of a domain model, which were around entities. Entities have their own identities. Like they are not something which are just identified by their attributes. Unlike value objects exist because of entities. For example, if you take an hospital and a patient is typically an entity. Each patient would have its own identity, which could be, let's say, a government issued ID, whereas value objects could be like address of that entity. And how do you relate both of them is also something we discuss. Like value object cease to exist if the original entity is removed from the picture. So let's say if there's no patient, there's no patient address. Address in itself doesn't have any significance in that hospital domain, right? So that's the part we have covered till now. Now we go one level above value objects and entities, and we go into something which we call as aggregates. Unlike the general definition of aggregates that we follow in UC, which has been something like uh, a computation being done over a particular entity to come up with a particular value. It's not that sort of an aggregate. This aggregate is actually an aggregate of entities. Okay. And within those entities, there exists something called the root entity. So what a root entity is? A root entity is what that identification of aggregate should look like to the outside world. So I'll go deeper into this. Basically, let's take an example. Let's take example from loan context for that matter. Let's say we are doing a loan domain. And let's actually do this UC specific actually. There's a provider. There's a loan. Not going into details of like there's an application, etc. and all. They can also be a customer. Right. Then what else? There's a vendor who is providing you the loans. Now, what would happen in a loan? Loan would obviously, I'll consider this to be an application. It would have a specification. Um, in absence of a better term, specs would be something like let's say, what's the EMI of the loan, what's the tenure, and things around that. And it would have something like a recovery. Recovery would be everything around like the payback that you're getting from a particular user and things around that, right? It might also have things like credit assessment, etc., etc. Just doing a very basic domain model of it if I have to do it with very basic requirements, right? So provider, customer, let's look at these three for now. Provider, customer, loan. If I say my loan is not specific to a customer or a partner, like in the sense, it's not just modeled for one of these entities. It is modeled at a user ID level, let's say. A loan has a user ID as an attribute. And of course, once it creates, it has a loan ID, right? Then there's other stuff. Then in that way, it's not directly linked to your provider or customer for its existence. Correct. It is a capability. It is a user that is being issued a loan. It's not just provider, customer, just taking a random example. Maybe UC decides to do its UC backed loans uh, for maybe drivers which are associated to UC in UAE, let's say. Correct. So it's not coupled to any of these entities. It has its own existence. Even if this entity ceases to exist in UC, this can still happen with a customer, right? Same way if this seems to exist, this can still happen with a provider or a user, correct? So this is a separate entity in itself. This is a separate entity in itself, not going into like why it has to be, but I think it would be obvious by now. This would also be not touching vendor. How about loan specs and loan recovery? Like loan recovery, again, it would be a link to a particular loan, right? So in that sense, it becomes a value object, correct? Loan specs could be depends on how you model it. Is it a static thing? Is it a dynamic thing? Is there a set of rules which are established before you define a loan or before you issue a loan? Or is something which is determined at a runtime? But anyways, loan specs would mostly uh, be things like what we covered, my tenure, etc. So how would these relate to loan in that particular example? Would loan be having a reference to loan specs, or would loan specs be having a reference to loans? So for our example, let's consider loan specs is something uh, often values through which a loan has been issued. In that sense, it again becomes something of relevance after a loan has been issued. Again, becomes a value object, correct? So, and of course, one part I missed is entities can also have your aggregates can also have value objects for that matter. So now, if you see there's a clear boundary being built between these flows, if I look at this boundary, oops, this is one boundary. Let's say this is another, this is another, this is another. Now zooming into this basically becomes one of your aggregates. Now what's the relevant thing about this aggregate and what's the root object we talked about? So the rule said like all objects outside an aggregate are supposed to access aggregates and everything around that using the root object only, not through their direct reference. So in a normalized way, this would also have its own ID. This will also have its own ID. ID in the sense, if I talk in terms of DB, that's a DB generated ID, not like an ID or an identity that we talk of an entity. Correct. Even though these are value objects, they can, of course, have their own identifiers of sorts for that particular entity if it has multiple entries within that. So, if you look at it, uh, how should a provider, let's say, if we want to show an app, if we want to show an app for a particular loan, how's the recovery going on? Now, let's say for any reason, if provider will obviously have the user ID, even if it has the loan ID, should it directly just call this module and get the thing done? Or should it just depend on this thing and this particular entity or root entity should be the one governing all of this for the outside world? So what authors suggest is the latter approach, where instead of like every entity referring to every other entity in the domain of the aggregate, you have that root entity which does all the aggregations required, hence the word aggregate, to send it to the outside world. So the outside world should just have a reference at most of the root entity. When in this case, depending on the business use case, it could just be the loan ID or a user ID, loan type, or some other identification. And even if you have to fetch the specs of that or the recovery of a particular loan, or let's say for that matter, the loan history of a particular user, you will just use reference or references to this root entity. You wouldn't directly touch these. Now, coming to the relevance of this, or like, why is this even aggregate important and how does it help us in our overall exercise that we are doing? So one is, of course, it creates a clear boundary on the life cycle of things. Now, once you create a boundary like this of an aggregate, you're clearly saying if the root entity doesn't exist, none of these will cease to exist. Okay. So that is one. And that also makes sense here, right? If there's no loan, there's no recovery, no specs, no history. So that is one part of it. Second, it also tries to think in terms of like if you are doing a sort of a transaction on this aggregate boundary, like most often than not, if you are updating something in the loan recovery, you might end up updating something in this loans entity altogether. Like it could be some remaining amount or something like that. Or same way, like if something goes into loan history, it would have gone if this loan would have like commenced or some update might have happened. So a lot of updates or operations that might happen in this boundary might be transactional and might have to be very strongly consistent in that sense. Uh, so you are basically putting a boundary to like your strong consistency in that sense. Ki everything outside this boundary can be uh, eventually consistent, but here it has to be strongly consistent. As to the outside world, it appears at just one thing. It's your internal abstraction which is happening over it. So that's the other part. So one being life cycle, second is you have, of course, operating at them at the same time. They belong to the same bounded context. Apart from this, the other benefit you get out of it is that at the coupling level, if you have once you have drawn boundaries, everything in itself, if I talk in terms of your service structure, this is basically one module. Of course, it will have further module if I look at it as a microservice, but this becomes one module which is decoupled from your other modules. So if you draw these sort of a boundary, you might choose to do that in the diagram you are making, just to represent like what's your different bounded context of different uh, domain elements present in your diagram. You are in a way also carving way of how your code structure or your service structure might also look like. And hence it might uh, help you in scale your system, at least in terms of maintainability, better. Like you will be having a much more flexible approach of changing everything here, as it's not coupled to any other entity, any other important entity outside. So yeah, that's the basic crux around aggregates. There's another concept like author tries to touch on, which is like repository. What's a repository is if you go one level deeper into aggregates, like if you are writing code of it, you will obviously need some DB access, etc. So a repository is an abstraction over the models of your entities in the aggregate. Let's say in UC terms, you have that model folders in, let's say, this loan module. That model folder in itself is abstracting out one, the database technology that you have used, and second, the querying logic, the joining logic, etc. So that's another part the author touches on. So yeah, repository aggregates is factory, but we wouldn't cover that right now. So yeah, like the way you can operate on the information you have got from this particular session is maybe once you're drawing your diagram or to the part you have drawn till now, try to identify these boundaries of aggregates, and more importantly, try to identify your root entities. That was this is through which everyone is supposed to assess my bounded context, not through like this ID belonging here or here or here. Okay. So yeah, thank you, people.